A while ago, I did a spell of videos regarding solar-powered camping lights and USB rechargeable ones. And I did so in it. I thought, right, okay, let's take a break from that before everybody gets bored with these lights. But I recently came across this one and thought, you know, it's worth taking a look at this one now, mainly because it's making concerning noises. It's very loose and rattly inside. So I've put a little bit of charge in it. I tested the output at about 500 milliamps. The voltage went from about roughly 5 volts. It went down to about 4 volts. So it's not really going to put out a lot of current there. It's got one of these annoying solar panel and LED arrangements that you almost wonder if the solar panel is just designed to make the LED light, because at the slightest sniff of light, that will illuminate, and it doesn't necessarily indicate much is going into the cell inside. So this is a light in the front. It's got the two settings. It's got the high setting, medium setting, and off. So let's open it up. The LED array is a 4x4 parallel array, I presume. Let's see what's rattling about in here, just in case there's a loose lithium battery and conductive bits whistling around it. So it's held together with 4 screws. It's got this fairly densely packed solar panel in the back. Quite a lot of sections in it. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means it's putting out roughly 5.5 volts, which is reasonable enough. Right. Okay. Well, what I'm seeing so far is a set of cheap nickel metal hydride or NiCad cells. There's what was rattling inside. I can see 1, 2, 3 plastic spacers missing. So I've knocked one out already. Where's the other one? Is it underneath the circuit board? Or have I just knocked it somewhere else? Oh, there it is. The intensity for the... I'm guessing that they've got a couple of resistors here. 1.2 ohm resistors. That's brown, red, I think it's brown, red and gold. Let's take a wee closer look with the magnifying glass. Yeah, it's brown, red and gold. So they'll be doing the sort of intensity control. And here's the little circuit board with presumably just the standard little boost chip on it that you normally find in these things. Nope. It's got what looks like, I wonder if one of those is a chip or if it's just a couple of standard transistors. That is a bit weird. Quite a beefy inductor. That transistor-like device, 501C, and this other component, S8550, are they not just standard transistors? I'm not sure. That's strange. Maybe I have to investigate that a little bit later. The solar panel is held in by clips by the look of it. I think the solar panel might be the best bit so far, though I don't think it looks like a terribly high current one. It's done that thing where the strips are very, very black against a black background, so you don't really know what sort of area they're taking up in there. Yeah, this is altogether disappointing, particularly because A, it's broken and arrived broken, and it uses a kind of, I'd rather it had been a lithium battery in here. I wonder why they've chosen these ones. Let's get the plastic sleeving off this battery pack. Trying to get my scissors in here. And we'll see if they're marked at all. No, they look like fairly anonymous cells, but I'm guessing these just are standard nickel metal hydride or nickel cadmium. Very strange choice, very strange indeed. So altogether, if you see this type of light, I wouldn't actually recommend buying it. Oh, there's the cob has come off rather conveniently. I'll maybe keep the cob as well, that's quite nice. The rest of it is not so great, so only really worth scavenging for components. It's definitely not the best of the ones I looked at. It's a bit flimsy And it seems to have cut corners a wee bit too much to the point that the charging output isn't really that impressive, although it is impressive that if they've done that with standard components. That's quite interesting in its own right. So yeah, not the best. Ah, yes. It was predictable that I would not be able to resist reverse engineering this, particularly when I saw that it was producing a 5-volt supply with an inductor and what looked like a 2-transistor circuit. I had high hopes. It turns out those hopes were dashed, and one of those transistors is just a tacky little feature that lights the LED. But this component here, the 501C, is very interesting. So let's go over the circuitry from start to finish. So it starts off. Let's cover, what can I use to cover this? Let's cover it with this nano UV disinfection light type thing. So let's cover this part of the circuitry. So we've got the 3 nickel metal hydride cells, and I have to say that's them here. I split them apart, noting that they soldered onto the positive and the negative on this. Very odd that they actually soldered directly onto them. That's a bit taboo. It's not like they're going to burst into flames though, because they don't hold that much charge. I did try charging them in the charger by cutting them apart, stick them in the charger, and optimistically charged them at a very low current of 200 milliamps, and it immediately terminated the charge because they've got such a high internal impedance that the voltage just shot up, and when it goes to about 1.5, the charger will automatically terminate because it's playing safe. No normal good battery would go up to that voltage level unless it was completely charged, or if it was an alkaline cell, in which case the charger is going to play safe and not charge an alkaline cell, because they do explode if overcharged, because they form gas inside and sometimes don't have a good means to prevent that. But I digress. The batteries are shit. That was the point of what I was trying to say. The little solar panel is also, it's down here. It's okay. It's a generic solar panel. It puts out about, well, when held right up against my lights, it put out about 40 milliamps at 5.5 volts. So we've got the 3 nickel metal hydride cells, which are the main power in here. And we get the solar panel, which charges them via this diode. The other way you can charge them is via the micro USB port. The micro USB port is very, very interesting. It's just connected in parallel with the solar panel, so it can go through that diode and charge the batteries as well. And just to add the final bit in the icing, as long as either of them is active, current will flow through this 1K resistor and make this red LED light to show that it is charging. That's this LED here that was lighting up. This one down here. The micro USB connector is very interesting because it's a through-hole device, and you're thinking, the pins are so small, how could they make it through-hole? The answer is there are only 2 pins, the 2 outer pins, and they've got a very solid connection here. They've got the 2 solder pads here that mount the socket onto the circuit board, and then they've just got 2 well-spaced pins at the back that put power on. I wish I could find these connectors. I can find standard micro USB connectors. Hold on, give me a second here. I can find the standard ones, the surface mount connections with the little tiny pins at the back, but not the one that's specifically designed for plated through-hole. Not plated through-hole, but through-hole connection with those 2 pins. That would be very handy as a means of getting power, a means of using phone chargers to power electronic stuff. But anyway, the next bit of circuitry to take a good look at is this device here. It's marked 501C, quite hard to find. I didn't find it in that package, but it may be made by Ricoh. It's a boost converter that takes the voltage, initially the voltage, the supply from the battery runs through this inductor, quite a big fat inductor here, and it'll go through that diode and it will charge that capacitor up, and as soon as it does, this is powered from that. It's only got 3 pins. And it's got a pin to the negative rail, it's got a pin to the inductor, and then it's got that sort of pin there, which is its power supply, but also its voltage reference, because it's looking to produce a fixed voltage of 5 volts across this capacitor and the USB out. So what happens is that if it detects that it's getting powered, but the voltage is too low, it will start pulsing this inductor. And initially, when it turns the inductor on, current starts flowing, creates a magnetic field, and then it suddenly breaks it, and you get a spike of going through this diode here and charge the capacitor. So it charges the capacitor as a series of pulses until it gets to 5 volts, and then this just goes into sort of standby sleep mode until the voltage drops down below a threshold again. And that's the USB output. The chip I found only puts out, it's only rated for 250 milliamps, which does kind of explain why by the time I got to 500, the voltage was well down. In fact, probably approaching the voltage in the cells. The other thing, this transistor here, is a bit of a gimmick. When this is not running, this PNP transistor is turned off via this 10K resistor. It's just it's very close to the positive rail, so it's turned off. When this runs, it pulses this transistor as well via this resistor here, and the resistor turns on in brief pulses, and when it does, it charges this capacitor, so that when this is running, that capacitor will charge up to pretty much the supply rail, and then the raised voltage then goes through the 1K resistor and lights the LED again. So that means if you plug a load in, the LED will light as well. That gives that LED double function, a charge indicator and load being pulled indicator just purely by activity on this. And that is it. So what is there to say about this? It doesn't put out much current, it's got shitty batteries, it's got a average solar panel. It had a nice magnet. I stripped the magnet out, the rest is in the bin. The LED looks okay. The switch and resistor arrangement is typically what you would expect, but relatively speaking, compared to other solar camping lights I've looked at recently, this is what's technically referred to as a pile of shit, and is therefore not worth buying. But it was very interesting just to see this little regulator, that micro USB socket, and I'll be keeping the solar panel. This can be hacked into something else, as can the LED. So still worth stripping apart for the components.